Here we go, a short and sweet overview of transformations. We will look more at all of these when we get to, let's see, it's chapter 9 later on in geometry, but for right now we're just doing a quick overview. A transformation is an operation that maps an original figure, and we call that original figure the preimage, onto a new image. And looking at this picture here, we have triangle ABC being mapped onto triangle XYZ. And looking at this, you could say that A is mapped onto X, and you could say B is mapped onto Y and C is mapped onto Z. And you could write those out if you want to. It's not a huge deal if you don't. All of the transformations we're going to look at today are congruent transformations. Some other words for those that you may see are rigid transformations, meaning that none of those sides are changing length or none of those angles are changing measure. The reason we have this in chapter 4 is because we've been looking at congruent triangles and congruent other figures. All of these things will be congruent as well. And another word for that even is called an isometry. And that word again simply means that they are congruent or rigid transformations. These things all mean the exact same thing. Okay, so I thought what we'd do here is just kind of fill in the blank. This first one is a reflection, and you may have learned this before as a flip. It's being flipped over some sort of line. That line of reflection will be really important, especially as we do our work later in chapter 9. But here you can say that point A is reflecting to point F, C is mapping on or reflecting on to H, and B is mapping to G. The next one is a translation, and you may have remembered hearing that as like a slide or maybe even a glide. It's not rotating around at all or being flipped over. Everything's just sliding in some sort of direction. So here K is mapping to P, L is mapping to Q, and J is mapping onto M. And then the final one of our congruent transformations is a rotation. A rotation is a turn. You do need to locate the center of the rotation if you want to be specific, and also tell about like the angle and what direction it's going. So in this case, here is the point it's rotating around. We would need to tell like how many degrees this is. So if I had to take an estimate, I might say something like, that's like 75 degrees, or we'll look more at this in chapter 9. And you'll want to say which way it's going. And in this case, it's rotating. This would be clockwise. You won't have to do any of this yet. Today, you'll just have to kind of realize, like, is it a reflection, translation, or rotation? Should be a fairly easy section. Let's practice the way some of these will look. We just really have to write down which one of these it is, and once in a while it could be more than one correct answer. And if that is the case, I'm looking through these, I don't think any of these could be, but you may have some, you could really write either one. Looking at this first one, I know that it's not a reflection because there's no line. If it were a reflection, it'd kind of look like a mirror image of itself. A translation would be like a slide, and it's not sliding. You can see that this is turning or gliding depending on like which one you're saying is the image and pre-image. And so this one here would be a rotation. This next one, you can see here that there's this line and these points are flipping over the line or maybe going this way. It doesn't really say again. This is a reflection. And lastly, the arrows kind of help, but you can see that it's just gliding up, it's sliding up. That's a translation. So if you want to pause the video now and try the next three quick, you could. I'm just going to go over what the answers are to those. This is a reflection. The line of reflection would be right here if you had that drawn in. This one here is a rotation. Again, because I don't know which one the original one is, it really could be either way. And then this one is just sliding, and again, we don't have the arrow, but it's sliding one way or the other. So that's a translation. Sometimes the way the book does this is they have like some kind of real world examples of these. For this one, it's kind of modeling the slider door. This would be an example of a translation. And this one here, the footprints, this would be an example of a reflection. For this information here, what it wants us to do is it wants us to graph these. And it says that we want to graph the original in its pre-image, identify the transformation, and then it says that we want to verify that it's a congruent transformation. So that's going to take the most work. The graphing part's not too bad. I'll go ahead and kind of work on that real quick. Again, just like before, it might be helpful to you if you just kind of do this on your own instead of trying to like watch where I'm putting things. Oh, it looks like we have to go over just a smidge. So I'll just pretend like that went all the way over to -8. Oh, let's see, -8.5. There's K. But you could go ahead and do this on your own. I think what I'm going to do is just jump the video ahead here and have it look like what it's supposed to. So go ahead and pause it and just take as long as you need to. So a quick opportunity for a reward. Just want to kind of see who's getting ahead on these things. I thought I would give a small treat to the first 5 people in each class to come and tell me what their favorite movie is. Okay, here we are back again looking at this. I already did the graph. We need to identify the transformation. This one is a rotation. So I would make sure that I write that down. But then the most important part of this would be the verification. So to show that this is actually congruent, you need to show that these are congruent triangles. So the way that you're going to do that is you're going to have to show that all of these sides are equal in length to all the other sides. So we did an example of this where we had to find the length of all of these. Distance formula is going to be really important. I'm just going to kind of go through these real quick. I'll do a little longer version of the distance formula for the red triangle, and then I will kind of speed it up for the other one. So remember, for distance formula, what we're doing is we're subtracting the x values, subtracting the y values, and then squaring them and adding them together. So I'm just go ahead and getting all of these kind of set up so that we're just plugging numbers in, and that part goes pretty quickly. Okay, so for KL, I'll use red now. For KL, the distance between those x values being -8 minus -4. We've got to add the opposite there. And the distance between the y values, 5 and 6. When I subtract those, I get -4, and -4 squared is a positive 16. I subtract these, I get -1, and -1 squared is a positive 1. So that's the square root of 17. Looking at LJ, the distance between the x values, -4 minus -2, and the y values, 6 minus 2. Here I add the opposite. So this is -2 squared, which is 4, and this is positive 4 squared, which is 16. So this is going to be the square root of 20. And for this last case, I have -8 minus -2, adding the opposite, and 5 minus 2. So this one is going to be -6 squared, which is 36. And that'll be 3 squared, which is 9. And this is the square root of 45. I could come up with decimal approximations for those, but it's not going to be necessary. I really just want to be showing that these are congruent, and you have to be writing that out to actually verify it. So the one that it looks like it's going to be the same length as KL, it looks like that one's going to be QR. So I need to find the length of QR, and again I said I just kind of shortcut this for you. So the distance between those x values, if you subtract them you get 4, and 4 squared is 16. And the distance between those y values, you can even just like look here how far apart those are, that's 1, and when you square that, that's still 1. So that's going to be the square root of 17, so I'm off to a really good start. For this next one, LJ looks like it's the same as PR, so I need to find the length of PR. The distance between the x values, 2 and 4 is 2, and 2 squared is 4. And the distance between those y values is 4. 4 squared is 16. So that ends up being the square root of 20. Again, those are congruent, so that's good. And the last one is PQ. The distance between those x values, 2 and 6 is 6. Or I'm sorry, 2 and 8 is 6. I misspoke there. That squared is 36. And the distance between those y values, -2 and -5 is 3, and 3 squared is 9. So I know I went through those pretty quickly. Hopefully you could just kind of do those on your own. And you can see here that I have verified that this is a congruent transformation because I have shown that the side works here. I have 3 pairs of congruent sides.